There's a powder that costs $2 and eliminates engine wear permanently. Not reduces it, not slows it down, eliminates it at the molecular level. A single application bonds to every metal surface inside your engine and creates a self-lubricating barrier that synthetic oil cannot match, that conventional additives cannot replicate, and that the $150 billion lubricant industry has spent decades making sure you never hear about. NASA used it on the moving joints of the Voyager spacecraft in 1977. The same probe that has now traveled beyond our solar system, still functioning after nearly 5 decades, was partially protected by this compound. You can buy in a small bag for less than the cost of a fast food meal. The United States military applied it to artillery mechanisms, helicopter gearboxes, and submarine propulsion systems throughout the Cold War. Racing teams in Formula One quietly introduced it into drivetrain assemblies in the early 1980s and refused to publish exactly what they were using. The compound is called molybdenum disulfide. Mechanics call it moly. Chemists call it one of the most remarkable solid lubricants ever discovered. And the oil industry calls it something else entirely. A threat to everything their business model depends on. This is the story of the mineral that empires trusted to protect their machines, that space agencies used to reach the stars, and that a handful of corporations have kept buried in technical datasheets for 70 years because a $2 solution is not an opportunity. It is an existential problem. Welcome to Fixvival. If this knowledge matters to you, subscribe and hit the bell. This is where we open the vaults. Let me take you back to the year 1778. A Swedish chemist named Carl Wilhelm Scheele is working in his laboratory in Uppsala, surrounded by mineral samples collected from across northern Europe. Scheele is already famous. He has already discovered oxygen, chlorine, manganese, and barium. But one sample on his workbench is giving him trouble. It looks like graphite. It writes like graphite on paper, but it is heavier than graphite, and it does not behave like graphite under heat. When he analyzes its composition, he realizes it is something nobody has ever formally described before. He names it molybdenum, from the Greek word for lead, because miners had long confused it with lead ore. What Scheele has actually identified is molybdenite, molybdenum disulfide in its raw natural form. A crystalline mineral that forms in sheets, layer upon layer, separated by forces so weak that the layers can slide over each other. He does not yet know what he has found, but the Earth does, because molybdenite has been sitting in rock formations across the world for hundreds of millions of years, quietly doing one thing better than almost any substance, making surfaces slide against each other as if friction does not exist. For over a century after Scheele's discovery, molybdenite was treated as a geological curiosity. Miners noted that tools cutting through molybdenite deposits stayed sharper longer. Machine operators noticed that any mechanism contaminated with the dark gray powder ran quieter, cooler, and with less resistance, but nobody connected these observations to a unified principle until the industrial era forced the question. By the 1890s, the explosion of industrial machinery, steam engines, factory presses, early automobiles, created a new and desperate problem. Metal surfaces grinding against metal at high speed and high pressure destroyed equipment at catastrophic rates. Factories in Britain and Germany burned through bearings, gears, and drive shafts at a pace that threatened to make manufacturing economically non-viable. Engineers were using animal fat, whale oil, and primitive mineral oils, but nothing worked well enough under extreme pressure. Metal kept destroying metal. In 1913, a German metallurgist named Friedrich Lavesse published a detailed crystallographic study of molybdenite. He documented what Scheele had only glimpsed, that MOS2 has a hexagonal crystal structure where sulfur atoms form sheets separated by molybdenum layers. The bonds holding these sheets together are extraordinarily weak, what chemists call van der Waals forces. Under any mechanical pressure or shear stress, the sheets simply slide apart from each other rather than resisting. Lavesse described it in his published notes as a material where friction essentially apologizes for existing. By the 1930s, engineering firms were experimenting with MOS2 as a dry lubricant for applications where liquid oils failed. The Second World War turned experimentation into urgency. Aircraft engine components needed lubrication that would not freeze or burn away. Molybdenum disulfide passed all 3 tests simultaneously. And then, in 1957, the race to space gave MOS2 its most dramatic stage. Engineers at NASA's JPL were designing mechanisms that would need to function in the vacuum of space, where no liquid lubricant could survive. They applied it to the joints and bearings of the earliest American satellites. They trusted it with equipment that could never be serviced. It did not fail them once. Now let me show you exactly why this compound does something that no liquid oil on the market can fully replicate. Because once you understand the chemistry, you will never look at a bottle of motor oil the same way again. Every engine wear problem comes down to one thing: metal touching metal. When 2 metal surfaces slide against each other, The microscopic peaks and valleys on each surface, which every machined metal surface has, can collide, deform, and tear away from each other. This is called adhesive wear, and it is why every engine on Earth slowly destroys itself from the moment it starts running. Liquid oil works by creating a thin film between the surfaces, so the metal peaks never quite touch. It is an elegant solution, but it has one fundamental weakness. The oil film can be pushed out under extreme pressure. Under high load, the oil film collapses. This is called boundary lubrication failure, and it is the leading cause of engine wear under real-world driving conditions. Molybdenum disulfide does not work this way. MOS2 does not create a film between surfaces. It bonds directly to the metal surface itself. When you introduce MOS2 powder to a metal surface, the sulfur layers form a chemical bond with iron atoms in the steel. The compound essentially fuses with the metal, creating a new surface layer that is permanently self-lubricating. The coefficient of friction of MOS2 is between 0.03 and 0.05. The best synthetic oils sit between 0.08 and 0.12. Steel sliding against steel without any lubrication sits at 0.5 to 0.8. MOS2 performs at friction levels lower than any liquid lubricant. The crystal structure itself has made friction geometrically difficult. The layers of the crystal simply do not resist sliding. Researchers at the University of Leeds documented that MOS2 particles form a tribofilm within the first 5 minutes of contact. The film remains intact even when the oil is drained. The metal is no longer metal sliding against metal. It is MOS2 against MOS2. The compound does not lubricate the engine. It becomes the engine's surface, and what it becomes, it stays. A 2016 study showed that MOS2 treated engines had 47% less cylinder wall wear and 52% less crankshaft bearing wear. These are not marginal improvements. These are the kind of numbers that should be in every automotive engineering curriculum on Earth. Now here is where the story takes a very dark turn. I want you to follow this logic carefully because this is not a conspiracy theory. This is elementary economics applied to a technology that threatened an entire industry's reason for existing. The global engine oil market generates approximately $150 billion in annual revenue. That number is not built on making engines last longer. It is built on a consumption cycle. You change your oil every few thousand miles, you replace filters, you buy additives. The entire revenue architecture of the lubricant industry depends on one foundational assumption. Engine oil is a consumable that must be continuously replaced. Now consider what happens if a $2 powder treatment bonds permanently to your engine's metal surfaces and reduces wear by nearly 50%. Your engine lasts dramatically longer, potentially tripling its service life. Your oil change intervals extend because the engine is not generating metal particulate. A permanent solution to engine wear is not a product the oil industry can sell you. It eliminates the need to sell you anything again. By the 1960s, independent additive companies began marketing MOS2 treatments directly to consumers. Products like Molycoat appeared in auto parts stores. Mechanics reported startling results: engines running quieter, fuel economy improving, and compression holding steady in high-mileage motors. The products sold very well. And then, in 1972, the American Petroleum Institute issued a blanket advisory warning consumers against using solid particle additives in motor oil. The stated reason was that particles could clog oil passages. This advisory was repeated in service manuals and publications throughout the 80s. What the advisory did not mention, the particle size of MOS2 was smaller than half a micron, far below any filter's threshold. The concern was technically impossible, but the API had the distribution networks to reach every mechanic and journalist in North America. By 1985, MOS2 had vanished from mainstream conversation. Independent companies folded or were bought out by larger corporations who discontinued the lines. The knowledge did not disappear. It retreated into aerospace engineering, military maintenance, and the notebooks of a small community of expert mechanics. These experts had seen what the compound could do and simply refused to stop using it. But the compound never stopped working, and the communities that kept using it kept documenting the results. Inside the vintage motorcycle restoration community, a world of high-mileage British and American engines from the 1950s through 1970s, MOS2 assembly paste has been a standard practice for decades. Restorers apply MOS2 paste to every bearing surface before initial startup. The reason is pragmatic. During the first few minutes of an engine's life, before oil pressure stabilizes and reaches all bearing surfaces, metal contacts metal in the most destructive way possible. MOS2 ensures that even if oil pressure takes 30 seconds, the surfaces are protected. Ask any experienced vintage engine builder and they will tell you that a properly MOS2 treated assembly startup sounds different, quieter, smoother. In 2019, a retired automotive engineer in rural Colorado began a documented long-term experiment on a 2001 Ford F-250 with 280,000 miles. He added a properly prepared MOS2 oil suspension at a 0.5% concentration and filmed compression tests and cold start behavior. Results showed compression readings stabilizing, cold start noise reducing by 40%, and oil consumption dropping significantly. The truck crossed 400,000 miles during the experiment. The engine had never been rebuilt. The original bearings remained in service. Academic research has continued in parallel. A 2021 paper from researchers at Chalmers University documented friction losses reduced by 18%. The friction reduction persisted even after the oil was replaced with fresh, untreated oil, confirming the tribofilm bonding mechanism. The protection did not leave with the oil. It stayed in the metal. In the overlanding community, MOS2 dry lubricant is an open secret. Expedition drivers crossing the Australian outback and the Sahara treat their drivetrain components with MOS2 before departure. They credit it with keeping mechanisms alive through conditions that have destroyed identically equipped vehicles running only conventional lubricants. If you have made it this far, you already know more about engine protection than the average mechanic of 20 years. Subscribe and share this with someone who is watching their engine age. Everything I have collected is in the Complete Forbidden Camping Vault. Link in the description. Now stay with me, because the next part is what they absolutely do not want you to find in a hardware store. Here's exactly what to do. And I want to be precise with you, because the method matters as much as the material. Molybdenum disulfide is not magic. Applied incorrectly, it does nothing. Applied correctly, it changes what your engine is made of at the surface level. What you need, technical grade MOS2 powder with a particle size of 0.5 microns or smaller. This is critical. Coarse powder larger than 1 micron can interfere with oil filters. Fine powder passes through every automotive filtration system without issue. A 100-gram bag costs between $8 and $15. That contains enough for 15 treatments. Your cost per treatment, under $2. Holes 01. Perform a normal oil change first. Start with fresh oil. You want MOS2 to bond to clean metal surfaces, not sludge. 02. Measure 4 to 5 grams of MOS2 per quart. A 4-cylinder needs 25 grams. A V8 requires 28 to 35 grams. 03. Mix the powder into 1 quart of oil before adding it. Shake or stir vigorously. The oil will turn almost black. 04. Add the mixture with the remaining oil. Start the engine and idle for 10 minutes. MOS2 is carried to every bearing surface. 05. Drive normally for 500 miles. Heat and pressure complete the molecular bonding process at every metal-to-metal interface inside the engine. 06. At your next oil change, the tribofilm remains bonded. A maintenance dose every second or third change is sufficient for peak protection. For mechanical gear, MOS2 dry lubricant spray follows the same principle. Spray it onto chains, hinges, and any metal contact point. What remains is a dry, dark gray film that does not attract dust, wash away in rain, or freeze in sub-zero temperatures. For vehicle differentials, apply MOS2 at a 2% concentration. It outperforms every synthetic gear oil because it bonds directly to the gear surface. Total investment, under $2. Compare that to the $600 additive packages sold at dealerships or the $4,000 cost of replacing bearings. A retired mechanic in northern Alberta told me, "Every engine I treated with moly lasted longer than the company expected. Every engine I did not treat needed rebuilding on schedule. The company never asked why, and I never volunteered the information. Some things you keep to yourself. Think about every engine that ever failed before its time. Every truck that died at 180,000 miles when it should have reached 400,000. Every motorcycle that seized on a mountain pass because the oil film failed under load. Every generator that quit on the third day of a power outage because the bearings wore faster than anyone planned for. Every piece of equipment that cost someone their savings to replace when it could have been protected for less than the cost of a meal. The mineral that could have prevented all of it has been sitting in the earth for hundreds of millions of years. Swedish miners tripped over it. Carl Wilhelm Scheele named it. NASA trusted it to reach the stars. The United States military used it in every weapon system that mattered. And a single advisory from companies that profit from your engine dying was enough to make you forget it exists. Molybdenum disulfide does not care about market share. It does not care about brand strategy or quarterly earnings calls. It is a law of crystallography, not a product. The hexagonal lattice structure of MOS2 was not invented by an engineer. It was assembled by geological processes over timescales that make human industry look like a single afternoon. You cannot patent a mineral. You cannot trademark a crystal structure. You cannot build a monopoly around something that comes out of the ground. What you can do is make sure nobody is talking about it in the places where ordinary people make decisions about their machines. But quiet suppression has a weakness. It depends on forgetting being permanent. It just needs someone to remember out loud. Every engine running today has metal surfaces that have never been treated with the compound NASA trusted to reach the stars. Every piece of gear in every truck bed, every tool in every camp kit, Every mechanism in every overlanding rig is wearing down. The knowledge was never destroyed. It was priced out of your awareness, buried under marketing budgets and trade advisories. They represent the full scope of what is profitable. Those are not the same thing, and now you know the difference. Subscribe and share this before the algorithm buries it. Every share is a crack in the wall they built around knowledge. The next vault opens soon, and what is inside is something every person who has ever paid an electricity bill should know.